Hello there and welcome to Asiantuntija Vol 2.0. Today we will be speaking English as we have an international guest with us today. Have you ever thought about the future, more specifically 10 to 20 years from now? It is inevitable that there is going to be some changes on how we are going to conduct ourselves in our professional life, on our personal life, etc. This is not only because of the advancement of artificial intelligence, but that is going to be our topic today. We are going to discuss how artificial intelligence is going to affect how we are going to work in the future as experts, as consultants, as coaches. For me, it has always been a very fascinating topic, especially if we think how the things were 20 years ago and how the things are now and how the work of experts have changed during these 20 years. And assume at least a little bit of acceleration for the next 20 years. I think it's inevitable that we are going to live in a world that is much more different than it's now. Also, if you take into account the discussions and also the hype, the sci-fi of artificial intelligence being this sort of machine that is going to take over in form of Arnold Schwarzenegger and destroy humanity. Is this a reality? I don't know. That's why I'm so interested in this discussion. I will be interviewing Tomasz Mucha, who is a doctoral researcher at Aalto University. And we are going to have a very interesting discussion on how artificial intelligence is really going to affect our lives, personally, but also professionally as professionals, experts, coaches, consultants. So without further ado, let's start and kick off the conversation with Tomasz. And we are live. Hello there and welcome to Asiantuntija Vol 2, or in this case I would say Expert Volume 2.0. Today we are going to discuss a very interesting topic related to the future, how we are going to work in the future, and how is the life and working life for experts, consultants, coaches, information workers going to be changed by artificial intelligence? And today we have very interesting guest from Aalto University, Tomasz Mucha. Welcome.
Hi, Petteri. Great to be here.
All right. So, can you tell a little bit about yourself? Where are you from? How did you end up working with AI? And who are you basically?
Yes, sure, of course. Yes. So my name is Tomasz Mucha. I have a professional background. So even though right now I'm at Aalto University, I have about 10 years of working life experience. So maybe before I even jump there, because now we're speaking English and this podcast is typically in Finnish. So why we're speaking English? That's because originally I'm not from Finland. So actually I come from Poland, but I studied at Helsinki School of Economics already more than 10 years ago. So that's how I ended up in Finland. And then most of my professional life has been here in Finland. So I have background in finance and business development. I worked in a corporate world and in startup world, and also did some consulting in between. I have been doing credit analysis for Nokia. So trying to understand what is the risk for Nokia to sell on credit, right? So for example, Nokia would sell phones to operators, mobile phone operators somewhere in South America, for example, but then they have 20 days to pay back. So what is the risk that they will not pay back? So I was trying to figure that out. Then when I moved to startup world, I was arranging funding for renewable energy technology company. and then also working in business development context. As a consultant, I have been advising companies related to financing and let's say analyzing new business opportunities. So I think that's in brief when it comes to my, let's say, professional background outside of academic world, and then how I transitioned to AI. So about 2 years ago, AI was, or let's say, discussion about these topics have been around, and because I have been working with engineers and technology, I've been always interested in tech, let's say. So I started to investigate artificial intelligence more, and also validate with business professionals across different industries in my network. And it's turned out that already at that time, people were saying, this is actually real. This is not just, of course, there is hype, but this technology is really entering into the businesses. So I thought that this was a good moment for me to step back, to learn a little bit more on what is the intersection between this technology and strategy. So I started my doctoral studies at Aalto University, Department of Industrial Engineering and Management, focusing specifically on this topic. So what is the business value of artificial intelligence technologies, and how companies can take advantage of this. So now it's 1.5 years since I've been in that role, and it also gave me, other than let's say studying the academic context, I have been also working with quite many Finnish companies. So I participate in Finland's AI Accelerator, which is Finnish government-funded initiative to really help Finnish companies speed up and take these technologies into commercial use. So I think that's a brief background about myself and how my let's say experience relates to this topic.
All right. So for myself, and possibly for many other people who are not so in deep in this topic, how could you describe sort of at which stage of development are we regarding AI and implementing AI to, let's say, for businesses in general? How would you assess the situation at the moment?
Sure. So maybe before I go there, I think it's worth to just clarify a little bit about what is it that we're actually talking about, right? Because there's a lot of misconceptions or misunderstanding about AI, and I think there's a good reason for that. So there's this kind of joke that AI is everything that computers can't do yet. So 10 years ago, it was speech recognition. Now speech recognition becomes kind of bread and butter activity. So everyone thinks that AI is something more complex. And then 50 years ago, optical character recognition, that so basically recognizing the letters on a PDF document or a picture, used to be AI. Nowadays, it's not AI, it's OCR, right? So there's a lot of, let's say, expectations about what AI is, but in the current context, most people, let's say, when they talk about AI, they mean machine learning. So that is, let's say, a subset of techniques that essentially map input to output, but they don't do it in a kind of traditional way how you do it with programming. So, for example, with a traditional approach to programming, you have certain inputs and then you have instructions. If something happens, then do that. So we have input to output. But with machine learning, you don't define this function, that this if-then rules, but rather you say, this is the input, this is the output, computer figure out what is the relationship between inputs and outputs. And by giving a lot of examples that link input and output, you can train different machine learning models to figure out this mapping function. I don't know whether this was too technical, let's say, description, but
maybe if you could sort of clarify input output.
Mm-hmm. Yes, sure. So let's say we have I'm driving my car to a parking lot in a shopping center, right? So, and there's a gate. This gate has a camera, and this camera recognizes my car registration plate. So how this is actually happening? So there's a model that has been trained to recognize letters, and how it's done. We have, let's say, 100,000 pictures of registration plates, and we know what are the letters there. So we show this picture to our model, and then the model is, let's say, guessing what are the letters. If it's guessing right, then it means then it's getting it's working fine. If it's not getting right, it needs to readjust the way it's approaching it, and we are changing this algorithm as many times until it's getting the correct answers most of the time. So this is the training process. So we have the inputs, the pictures, and then the outputs, the actual letters. So when we present a lot of examples, then finally the computer can learn what is this mapping between the picture and the letters. Yeah. Was this a better explanation?
Yeah, and is this also the reason why data is becoming more and more valuable? Because the more data you sort of give to the machine, the better it becomes in its assessment.
Yes, I mean, that's right, that without, when we're talking about this machine learning context, without data, you can't train these algorithms. When we're talking about this kind of approach to machine learning. So the companies that have a lot of data, but it's also data that needs to be good quality, and data that well, there's this kind of label, so that we actually know what is linked to this data. Like, for example, a picture of a registration plate and letters, and whatever. If we are thinking about a model that assesses whether this is a good or bad customer, so it's not only the information about that customer, but also evaluation whether this was actually good or bad customer. So companies that have this kind of rich data can use this in training models, right? So let's say that this in a way covers the introduction of what is it that we're actually talking about. So we're talking about models that can learn, and they are in computers, and they take a lot of examples to figure out what is the connection between these inputs and outputs. So now, coming back to your original question. So what is the current state of use of these technologies? So actually, there's a very wide range. On one end, there are companies that are not using these technologies, and they have actually a lot of difficulties when it comes to finding a way to apply these technologies. And the reason for that is actually data. So as we discussed just a moment ago, if you have a relatively small company that has, let's say, few customers, they might not be able to generate enough data to train the models. But there is some positive news for these companies as well. So there's a lot of tools that can leverage AI for some very specific tasks that are more general, not specific maybe to that business, but used in different contexts. So let me give you just one example. Most of us, when we type messages on a phone, for example, we use this prediction or auto-completion, right? So we start to type first few letters, and then the word appears. And for many of us, these are actually the words that we intended to write. So we can speed up writing. Myself, for example, I'm using a lot of text to speech. So instead of reading documents, I have a computer reading it for me. And I can speed up my reading, so the way I absorb content. So there are many tools that leverage these technologies that small companies can use. So this is, let's say, one end. There's another end, and these are companies typically in, let's say, technology field, finance, telecom. So some of these companies actually are very advanced already, and we have good let's say examples in Finland. Companies that have already tens of people involved in operations related to machine learning or artificial intelligence activities, and companies that not only are able to use these technologies to generate, let's say, business value for their companies, but they are actually able to develop the technology. So they have technical know-how. They are not only buying tools from someone else, but they're actually developing in-house. So there's a wide range, and I think maybe the difficult middle is for let's say middle-sized companies that are already could benefit maybe from these technologies because of the volume of data, but maybe they don't have enough know-how, technical know-how. So that's probably the area where there's biggest opportunity to benefit from these technologies if we can get people to learn more and figure out how to use these technologies.
All right. Maybe I think one of the most common question relating to AI when it comes to people who are not so familiar with this topic is that, is AI going to take my job? Am I going to be useless? And especially in information work. Let's say you are doing very simplistic tasks with Excel or something like that. Is it inevitable that we become useless as AI is going to be taking over?
Well, I don't think that we are close to this kind of situation that AI technologies are substituting people. But these technologies, like I mentioned, they are very good in specific tasks. So because most of the people, when we talk about let's say consultants, professionals, or experts in specific fields, we do more than one thing in our daily job, and it is hard to substitute a person with an algorithm that would do everything, the same things that a professional or expert does. But individual tasks can be substituted. So now the question is how easy or feasible it is to automate these tasks. And actually, I think 2 or 3 days ago, I talked to several people who have, let's say, similar area of expertise, and that is related to credit risk analysis. So I talked to people in banks and other financial institutions, and there was a very interesting contrast because in one context, in a bank that is not, let's say, very big, but a bank that deals with big customers, they didn't see so much, let's say, upside that they could get from using these technologies in analyzing customers. And why is that? Because every case is different. They have big projects or big funding that they are investigating, but there's relatively few of these. And then a few hours later, I talked to another person that works in context of company that arranges funding for other, let's say, manufacturers of equipment and retailers, and they have a lot of data where individual cases are relatively small, but the volume is very high. And then they said that they see very little role that credit analyst plays, and it continues to shrink the responsibility because credit scoring models and algorithms are actually doing very good job there. So this was an example of it's a similar context, but very different setup in terms of the volume and importance of individual transactions. So that let's say varies a lot. Now, so coming back to your question, is AI going to replace me or my job? So I think there's a very good reference. I would recommend your listeners to check it out. There's a book by Kai-Fu Lee, AI Superpowers. And on the website that is covering that book, he has also this kind of AI job displacement index. And in there, he tries to evaluate what is the, let's say, probability of jobs being replaced in another, 5 or 10 to 15 years. And the key, let's say, drivers of that is how much, let's say, human interaction there is, how structured the environment is, and then also how repetitive the tasks are. So let me give you an example. So if you have, let's say, in a medical context, so there's big differences. So for example, a general practitioner, a doctor that needs to, well, not only discuss with people, but there are very different cases. You need to be able to investigate and kind of try to understand the context of that individual person. So it's quite hard for our system to be, or an AI model to be able to capture all this kind of differences. But then you can have a radiologist that receives a picture or someone who looks at X-ray, and their daily job is about evaluating these pictures and trying to find some individual details on these pictures. So this is in a way this kind of danger zone, because this can be automated by an algorithm, right? So it's not even about the industry or company, but it's really about the individual tasks. And I think this context is another thing. So how structured the environment is. So let's say someone who needs to well, not only work with different people, but travel a lot, or discuss with or visit on site to different companies. It's very hard to substitute someone with that role. But if you're working in back office and you have a lot of repetitive tasks, then it's probably very much easier to find an algorithm or train an algorithm that will do similar tasks. Yeah, so it's long answer, but I think there's no this kind of black and white that you can say that AI is going to take jobs or not. It really depends on what kind of tasks these jobs include. Yeah.
And possibly when we think about human interaction, that's something that is not going to be automated or replaced in any time soon. And when you're dealing with people are not rational for the algorithm to sort of understand very simplistically. I assume that's something.
I would say it again depends on the context, right? And the volume of operations, because even though you have this maybe irrational component, but if you have hundreds of thousands of similar types of interactions, you start to see the pattern. So one example is customer service. For example, this chatbots and automated customer service is one area where there is let's say a lot of activities related to AI. So one thing is if you're working with a chat, so you already have information in text format, it's much easier for a machine to interpret that. And then you have specific questions. So customers tend to come with similar questions. And it actually turns out that in some contexts, companies that are using these chatbots, they see customers preferring to go to chatbot rather than a customer support agent. And this is because they don't have to wait, and they will get let's say the link that they can maybe click and go to see the exact answer that they're looking for. Of course, it depends on the context, but there are companies that are already experiencing that.
Yeah.
But then if you have more complex type of interaction and you need to build a relationship with well, your customer or supplier or whoever, then of course this human role is much more important, and this is not something that computers are going to be replacing.
Yeah, I actually think I read an article, like I think it was like 1 month ago, that it was some sort of study or research that people are more willing to interact with bots because you can hurt bots' feelings, but you are less likely to hurt another human's feelings.
Yes, I mean, there are some interesting, let's say, psychological things. So one company that I talked to, they did, let's say, customer survey and analysis of interaction with bots. And one surprising thing that they found was that some of their customers were avoiding maybe this interactions, or had some negative feelings because they felt that the bot can't understand what they're saying, and they felt bad about that they can't express themselves clear enough for a bot to understand. So it actually there's big variety of responses, and there are going to be new let's say potentially challenges or new situations that companies haven't faced before. Well, one example is this auto completion and let's say prediction of the text that you're writing, right? So we are thinking that, okay, this is something that speeds up our work, but it's also actually driving what we are writing. So there is very recent research on that topic. They were comparing two groups that were supposed to describe what's on pictures, and this group that was using auto-completion would have much lower richness and lower variety of in the description. So it's actually that this tool is also impacting the content. It's not only the speed, but it's actually what you're getting. So there are going to be some new, let's say, learnings about the interaction.
Yeah, that's going to be interesting. That are we going to, or how we are going to communicate with AI, because it seems that it's inevitable that we are in some way going to interact with each other, AI and people. Do you agree on?
I mean, again, I wouldn't want to have this kind of general label AI. So we're always thinking about some specific algorithms or implementation. So I don't think it's let's say fair at this point or anytime soon to be talking about AI as a kind of intelligent being, because we are talking about algorithms that are mapping inputs to outputs, and that's it. And if you go beyond the context where they have been trained, there's no let's say there's no common sense. They just don't know anything. They don't know the world except for the examples that they have been shown. Yeah, I think this is some important clarification that I would like to make. So when it comes to interaction, yes, for sure, we are going to interact like with chatbots or well, whenever we're using this technology, like image recognition. So we have I think Sony just recently took to market a camera that automatically labels your picture. So what is on your picture, right? So I mean, is this interaction with AI? I don't know. It's just automation of some of the tasks that we would be doing. And another thing is that I think it's important to learn about these technologies, because I think many people in a way are exposed to them without knowing. So when it comes to, for example, online advertisement, where these technologies have been used a lot, understanding that basically whether it's Google or Facebook, they are tracking your activity, and the algorithms are testing on you your response. And because they have thousands of examples or millions of examples, they will learn how to what is the combination of messages to get you respond and click to advertisements, for example.
Yeah, I do Facebook and Google advertising myself, so I have figured that it's better for the algorithm to actually decide to whom show the ads, because it has a way more knowledge and data on who is going to be the most probable person to click on my ad.
Right.
Yeah. Maybe do you think that in the future we have to learn how to also code, or somehow understand how these different, let's say, segments of AI, if that's correctly put, for example, machine learning, do we have to understand how it works? Do we have to know how to code?
Mhm.
What do you think?
I think I would make a distinction between coding and this kind of systematic way of thinking, because one thing is to be able to write, let's say, whatever Python or C or JavaScript code that solves specific problem, and another thing is to think on a more conceptual level, what are the steps to solve that problem. So for people who are let's say have some experience with programming, there's a concept of how do you call it, pseudocode. So it's not a code, but it's something more abstract, some higher level concepts. So it's for example, if my location is Helsinki, show me the ad related to whatever restaurants in Helsinki. So this would be a pseudocode, and then the actual code would be the exact let's say lines of code that you need to write to figure out if you are in Helsinki. So what are your coordinates, how you check the coordinates, you make some API call to some other database. So this is kind of very detailed. And I don't think that coding on this level is required for everyone. But thinking on this more abstract level is something that is very important, because then even if you don't know how to code, but you can grasp this conceptual level, then you can discuss with coders, and you are able to follow when they are explaining to you what are the steps in the process. So I think this is enough for most people, and it's also a tool to understand, but it's also a tool to communicate. So if, for example, your other colleagues or subordinates, they do the coding, you are able to express in a way that they are able to implement and understand what you mean.
Yeah, it makes sense that you cannot be sort of the best expert in every single thing, but the more you understand the basic concepts of many things, it's usually enough. Then I would like to discuss the perhaps most hyped thing, the sci-fi, let's say, dystopia. Is there like any reality in the concept of singularity? First of all, could you sort of define what is meant by singularity, and how do you see this dystopian sci-fi future that is everywhere, basically?
Sure. Right. So what is meant by singularity is essentially the point where, let's say, algorithms or computers that are learning continuously accelerate their learning pace to the point where no human being is able to actually stay up to date or understand what computers are doing, and they become in a way omnipresent, omnipowerful, that can rule the world, and humans are no longer relevant species. So let's say that would be my quick own definition of singularity. And now what I think about it, so this is my personal view, and I think there's as many views as people who have been a little bit reading or studying AI. So personally, I don't think this is a real threat for us, but I recognize there's a lot of smart people who are thinking about it, and I think that this is good, that there are smart people who are concerned and they are thinking about it, because this kind of self-doubt is a healthy thing. So even though I'm very sure that this is not a problem, I think it's good that someone is thinking about that. And now let me tell you why I think this is not a problem. So I heard very convincing argument, and let me put it in this way. So first, when you want to continuously accelerate, it's actually very difficult. So let me give you a kind of simple conceptual example. So let's take a car, all right? A regular car that you're driving. Now, what do you need to do to get this car driving 300 kilometers per hour? Well, maybe you need super powerful engine and maybe different gearbox, right? Okay, let's say it's worked out. But what about this car? You need to get to drive 1,000 kilometers per hour. Okay, now the chassis is not good enough. But if chassis is not good enough, then probably your suspension is not good enough either. And at any point you will replace some component to overcome the obstacle, something else becomes a bottleneck. And if you want to continuously accelerate, it actually turns out that almost everything becomes a bottleneck, that it's increasingly, so as you want to go faster and faster, it's actually harder and harder and harder to accelerate. So this is this kind of conceptual, let's say, reasoning why I think it's extremely hard to, like in the kind of physical world, to really continuously accelerate. And there's another parallel argument, which I think is very very convincing for me. So when you try to think, what is the closest that we have on Earth that resembles AI already today? And we have had it for hundreds of years. And that is the whole, let's say, institution of science. So by definition, this is let's say, a system that tries to learn and continuously improve, right? That's what scientists do. They study the world, they try to understand it, and then continuously improve own understanding. So that, I think, is a fairly good, let's say, representation of what AI should be, in a way, doing. So now when we look at the track record of science and how important discoveries have been happening over time, so what we actually see is that we have this kind of linear growth. So this kind of big milestones in terms of the science and big discoveries are not happening increasingly faster. They are happening roughly at similar pace, but at the same time, science is consuming exponentially more and more resources. So when we look at number of people who are involved in science and the funding of science activities, it's actually becoming more and more harder and harder to stay growing at a kind of stable pace. So a kind of linear growth in terms of the big discoveries. So for me, this is a very convincing argument that even if we have a self-learning system, for it to, let's say, keep on learning very fast and continue to improve, it needs to consume more and more resources. And because resources are finite and they are expensive to get, for me, this is the kind of bottleneck that they will be limiting and growth of AI capabilities.
All right. Yeah, that makes sense. Usually when I see the opposing argument is that we are going to see the technology to accelerate exponentially, and that's usually the sort of main argument that I hear. And what is there is this
Moore's law.
Moore's law. What do you think about Moore's law, and can you explain it a little bit?
All right. So if I remember right, the whole idea is that every 2 years, for the same price, your computing capacity doubles. So if you have a computer that costs $1,000, and then 2 years later, you have a computer that costs also $1,000. So this newer computer is twice as good as the previous one. So this is exponential growth, and it's been well, happening at this pace. But now the computing capabilities might increase, but is this, or are continuing to increase, but is this enough for AI to be, let's say, reaching this super intelligence levels that we were talking about when we talked about singularity? I am not sure if this is enough.
Yeah, okay. And then there's this Turing test, I think, that is it something like if you would have a conversation with computer and then you are trying to assess whether it's human or computer, and the computer passes the test if it's able to convince to you that it is a human.
Right. So that's, let's say, the current or most common way that this Turing test is presented. So the idea, in general, the idea here is how can we measure intelligence of a machine? And well, Turing came up with this test with in a way, underlying idea is that something that resembles human intelligence so well that humans can't distinguish by themselves, then it's probably, we can say that this is an intelligent creature or being. But of course, there has been also a lot of criticism for this Turing test, and there's, I think, annually run this kind of competition of Turing that is actually implementing this Turing test, where there's I think multiple judges and people submit bots, so algorithms that are trying to that are discussing with the judges, and the judges are trying to figure out are these human beings or not. And what happens is that those bots that are using this kind of deception are most difficult to distinguish, that they are not answering directly to your questions, but trying to twist and go around your questions, might actually convince some people that, and I think, well, I think there's this kind of bot which was trying to play a role of a 15-year-old Ukrainian hacker. So it's always making jokes. Whatever you ask, it's twisting the questions. So of course, a teenager could be acting like this, but is this really a test of intelligence? I'm not sure.
Yeah, it's interesting. And let's say that there is a singularity already within us. Would it actually tell us or reveal it itself to us?
Right. Now that's the question that I think Matrix movie was trying to investigate, right? Because that's the kind of situation. So I don't really know. I don't have strong opinion on that.
Yeah. One thing I find very fascinating in terms of development of AI, and that's autonomous driving. Mm-hmm. I think there is at least Tesla, Waymo. Those are the two car companies I'm aware of, and apparently they are quite safe compared to human drivers. What do you think about, or do you have any opinions about autonomous driving? Do you think that it's going to be the future of transportation, whether it's commercial transportation or human transportation?
Right. So, well, I haven't been studying commercial autonomous driving myself, so it's more based on discussions and readings that I had in relation to AI. But let's say when it comes to the current situation, so the first question is, what does it mean that a system is really safe? So just this definition is actually already a big controversy. Is it enough that it's as safe as human driver? Or is it enough that it's 10 times safer? So it means that his system reaches about 10 times less accidents. Or it should be 100 times safer, right? So answering this question is already quite difficult. Of course, there are contexts where people had to make this kind of decisions, and I mean outside of autonomous driving, and that is in aviation, right? So there are systems that are in a way autonomous or automating certain tasks, and they have to reach certain performance standards to be accepted into use, but it doesn't mean that they are 100% always working. So there is still some probability that they fail. So now the question is for autonomous driving, whether or when there will be some kind of consensus of what is the right level of safety. And there have been already, of course, people investigating that when it comes to this kind of famous question in the autonomous driving context. So whom should the autonomous car be actually trying to save? So if you have this kind of situation that the autonomous car is driving and there's a child running in front of the car, and the car has only two options, either drive over the child, or turn to the right and drive through people who are standing on a bus stop. Right? So, and there's no other options. Let's say the road is in such a situation. And for human being, there is not really enough time maybe to make decision. But for a computer that can process at much faster pace and can, let's say, measure distances or evaluate this, there could be actually time for an algorithm to decide. So now this is this kind of ethical question. These are new questions for, let's say, computer science. So in many other contexts, like in chemistry, where there have been chemical weapons, or in nuclear power, there have been this kind of ethical questions investigated. But for computer science, they haven't been investigated as much. So this is an ongoing dialogue. And some of the findings are that actually it's culture dependent, culture and country dependent. So in different countries, answers are different, whether the car should save a child or a couple of passengers or people who are waiting on a bus stop. So in some countries, for example, people of higher age are much more appreciated. So it's much more important to save elderly people because they are senior. In other countries, a child will be more important because it has all its life in front of it, whereas the let's say more adult people are in a way have already experienced more in their life. So these are these kind of open questions. And they are not really resolved, and I think there's still quite a lot of work to try to figure out how to deal with this. When it comes to the safety levels, so as far as I know, not a single system is fully autonomous. So we are talking about autonomous driving, but it is at the level where there's a need for human interventions, and this is important because I think, well, people have this kind of tendency to extrapolate based on the examples. So if I am driving a car today and I'm controlling everything and supervising this autonomous driving, and it works fine, and next day is the same, and after a week or a month, I get used to it. Okay, it just works, so I can just go to sleep and save some energy while going to office or some other place. But this, we need to remember that these systems are trained on examples, and if there's something that hasn't been shown to the computer before, it might act in a completely different way that we would say a common sense driver can act. So yeah, I think it's difficult for me to say when we will reach the stage where on kind of public roads there will be fully autonomous cars, and we will be perfectly fine with that. But if we move to a structured context, so if you look at I don't know, airport or a port terminal where you don't have kids running around, you don't have bikers, and so there's access control, there are clear lanes, and maybe there's also much more sensors that you can install. Their autonomous driving actually is already taken into use. So I think it will vary. Yeah.
Obviously, it's difficult to answer to a question that's very, let's say, future oriented. I think you touched a very interesting question, and that was the ethics and morality of the, let's say, AI development, because every cultures obviously have different sorts of principles and morals, and we are raised in different contexts and differently by our parents. So is it when these systems are developed, there must be some sort of bias with the researcher? Do you think that's something? Do you think that's true, or what are your thoughts on that?
Right. So I mean, this topic is of extreme importance to people who work in, let's say, this kind of practical machine learning. So bias, it's not only the kind of ethical questions, but there's also very, very, let's say, data and algorithm specific questions related to bias. So I would say For sure, in many applications, bias is present, and there are already methodologies and let's say a lot of people working on well, establishing, say, standards or ways of approaching bias. So you have bias at different stages. Bias can be in the training data. So you might have, let's say, there is, well, for example, I talked to Yle, so Finnish National Radio and TV, and they need to represent in a way the full population of Finland and also cater to this. So if we had a system that you can, let's say, talk to, this is not the actual context or the actual example, like thing that they are maybe investigating right now, but just to give you an idea. So if they had a system that you can talk to Yle Arena and it would recognize your voice and you will say what program you want to watch. So they would need to account for people who speak Finnish, speak Swedish. They would need to account for people who are elderly, also the kids. And if they have a system that doesn't have enough natural voice of children speaking, it will probably not perform very well in recognizing what they're saying. So now they cannot really offer this kind of service because it would not fairly cater to all the Finnish population. So this training data is one level that you can have bias in. So if you don't have representative data of the actual population that you're trying to work with, then you will already immediately introduce bias. So let's say common example in the context of AI is in recruitment. So if you're using AI algorithms to screen candidates, and then you have your data on how from your past recruitments, how people performed based on the parameters that they provided in their CV at the time they were recruited. So now the question is, okay, can you use this training data to train the algorithm to filter good candidates? Well, one way to think about it is that yes, because it will give you the same type of candidates that maybe were performing well in the past. But if your current company already has bias that, for example, women are not promoted and they don't get opportunities to show their capabilities, then your algorithm will actually be biased against women and will say that most of the women should be filtered out from your candidates. So this is the training data problem with bias. Another thing is in the algorithm itself, you might, let's say, it might not process or the way the data is processed, it might also be biased. So one example is that there can be a leakage of information. So for example, you say, okay, I don't want to include gender into the data that goes into the training, right? So then I'm okay, they won't be biased in the data. But then model can actually learn about other elements that are related to gender, for example, name. And it can start to discriminate based on the name. And because female names tend to be given to females, it will start to discriminate based on the name that these are not good candidates. So this is another, let's say, potential problem. And then another thing is that also once the model is already trained into use and taken into use, there can be shift in the underlying population. So you might start to, well, now let's say we are looking at customers and we would be changing our segment, but we would still use the old model. So then it might start to, the bias might be introduced later. So there are many stages at which bias plays a role. And there are big companies that are working on these problems. For example, IBM has a full framework on how to investigate and deal potentially with bias. So it's a very big topic in this area.
Yeah, it sounds very complex when you have to take into account so many different variables and different things that may have that may affect each other on the way. And I can see that there's a lot of work to be done in that regard. Well, we are approaching to the end of this interview, and usually in these interviews, at the end of the thing, we put on a tinfoil hat and try to look into the future. So if you would have to describe future, how does the world look like in 20 years? After 20 years, where are we as a society with AI?
All right, so you want on a kind of very general level and not specific to, let's say, experts and consultants. All right, is that what you're after?
Yeah, just feel free to prophesize the future.
Well, I think that people will be very powerful because they will have access to technologies that we don't have right now. And if everything goes well, these technologies will be amplifying capabilities that people have, right? So, for example, in terms of I don't know, lifting things. You might have external skeleton that can help you do things that you don't have enough strength to do. When it comes to analyzing data, you'll be controlling with your voice applications on your computer, and the computer will be able to interpret what you actually mean when you say different things. So I think things will be happening at much faster pace in the business context because of this extra powers that people will have. So I think that's this pace of change. I think that's something that I expect is going to happen. And what that means is that people will need to be learning a lot. So I think learning will become even more important than it is now. How does that sound?
Yeah, it sounds like we are going to turn into cyborgs. Or I heard in one interview, I think it was a nice way of looking at it, that we are already kind of cyborgs because we have these mobile devices connected to us, and the sort of the thing to think about was that how much smarter are you with your phone or without your phone. So that's something I found very fascinating thought experiment. We are already sort of cyborgs.
Yes, I mean, since the beginning of human civilization, we have been using technology to enhance our capabilities, right? So even when you think about what kind of invention a hammer or an axe was, so earlier it was really hard to cut wood with your hand, right? So why not use stone? Okay, but why not use something better than stone? So the technology has been giving us superpowers for years, and now it gives us this possibility that we don't need to understand also more rudimentary things. So when you think about, for example, photography, it used to be that only people who actually understand optics and lighting, they can actually take good photos. And then, of course, you had to process the pictures in a dark room. Now you can have a digital camera and you don't need to know anything about optics and you can take great photos. Right? So I think the technology gives us this way that we can move to the next level of like focusing on more abstract things, and the lower level things are taken care of by the technology. So just the important thing is that there are still people that understand all the levels from the bottom up to the top. And so I think that this growth continues. So we need to ensure that we have full understanding.
Yeah. So you would say that you are hopeful for the future?
Yes, I think so. I'm optimistic in this respect, for sure.
All right, great. I think that's a good way to wrap this up. Do you have sort of, if you have some work or some social media or some, if people want to get hold of you, do you want to share them or?
Yeah, sure. So I'm happy to respond to any comments as far as my schedule allows. You can find me on Twitter, T_Mucha, that's MUCHA. And you can also check what I'm doing. I think I post every now and then what I'm working on LinkedIn.
All right. Thank you very much for this interview. It has been very fascinating and interesting.
Thanks, Petteri. It was fun.
All right. Bye, everybody.
Bye-bye.